So algebra 1B, we're actually going to be looking at over on the Wednesday column, even though we're on Monday column, even though we're on Wednesday, the 28th. But SWBA students will be able to solve systems of equations by graphing, okay? So, first thing I'm going to do is I'm going to write my name. Me llamo es Señor Castle. Okay? Okay. Oh, sorry. My name is Mr. Castle. Okay, yeah. It's a set of two or more linear equations containing two or more variables.
That's what I wrote down, but
I didn't know. Okay. So a set of two or more linear equations containing two or more variables is a system of equations, okay? Now, like I said before, they represent situations or solve problems related to consumer economics, finance, and geometry, especially economics and finance, okay? So they do have big usage, okay? So solving by graphing is the first method we're going to learn. Okay, we're reviewing it today even, okay? We're going to learn other methods later. Today we're just reviewing graphing to give us more solid base on this. So when two lines are graphed, they always meet at 1 point unless they're parallel or the same line. They're going to meet at 1 point. And where the two lines meet is called the what?
Yes.
Where is it called when they meet? They meet at 1 point and they intersect. Yep, it's called the intersection. And we write this intersection as an ordered pair, x, comma, y. Okay, x, comma, y. Okay. Aiden, you got this, buddy? All right, gonna take that as a probably not. Okay. Yeah, don't slap him. Or if you're going to, do it from 6 feet away. Okay? If you can find a way to do it 6 feet apart, I'll take it.
Is it 6 feet?
No, they're about 3 though. A little over 3.
Is that good?
Yeah, it's still pretty good. It's the best we can do in the classroom. Yeah, yep. In order for me to still have enough desks to teach, we can still do it. And so, like, if the actual desk is 3 feet, okay, that means like you and the person are even a little bit more than 3 feet. Does that make sense? Because like the edge of the desk.
why don't we just get those sheer tables that they put on desks so we can have them in the classroom?
I don't know. That makes sense. It'd be a good idea.
Or at the lunchroom, it's so boring without all my friends.
You have friends? Man.
Sadly, yes.
Oh. Well, there you go. One's better than none. All right, continuing on. Steps for solving them. So our first step is to put them both into slope-intercept form. Someone remind me, what is slope-intercept form? Y equals mx plus b. I'm going to put that little reminder on there too, okay? Then we're going to graph the first equation. We're going to use a ruler to draw the line, right? Because we need to be precise. Now, do you have to use a ruler? No, what else could you use? Phone, what else could you use? Any straight edge. Okay? You could use a ruler, you can use a phone, you can use a laptop, you can use a notebook, you can use a binder, folder, you name it, okay? As long as it has a straight edge, you can use it. Raise your hand if you need a ruler. Okay? You're good? Okay. I doubt it. I'd say bet.
Look,
Thanks, G.
it's a perfectly straight line. It's just not up and down. It's like a diagonal.
It's not perfect straight. It's pretty close though.
Thanks.
Yeah, I've seen worse.
Thank you.
You betcha.
Goodbye, Mason.
You would.
Alrighty, then we're going to grab the second equation, and then we're going to write where they intersect. Now in this first example, are they already in slope-intercept form?
Yes, sir.
Nice, okay, I want you guys to try this one. Okay, I want you guys to try this one.
Too hard.
So, we're graphing this, and Aiden, you told me the m of this first equation is what? The m of the first equation is what?
-2.
Okay, and what's the b?
-1.
Negative 2 over 1, what's the b, Aiden?
B is 1.
What kind of one?
Just, negative.
The negative kind. Okay, so we're going to go down 1. I thought you'd like that, Lainey. Okay? And you say you wouldn't say it for a full show, okay? Anyway. So our slope -2 over 1, we're going to go -2 down, 1 to the right, or -2 up, 1 to the left, okay?
You better love me.
Yeah, here.
And then the second equation, Tucker, what's my slope?
Second equation, your slope would be x over 1.
So just 1, right? 1 over 1. And what's my b?
5.
5. So I begin with b.
Brain fart.
Yeah, it kind of smelled bad. Okay. So now we have... Oh, man. I got my pink one off.
Yeah, you got the pink one off. I was gonna say something, but
Yeah.
I should have.
Bad line.
Man, I rely on you guys to help me out.
Nope.
And you're just like, nah, I'm going to let him struggle.
well, I didn't know
Why
if
not?
you were
Sorry.
wrong.
I was.
So then I just kept quiet
Until you knew for sure.
Yeah.
Okay, so what's my solution, guys? Where do they intersect?
3.
Negative 2, 3.
Negative 2, comma 3. Remember, we always do the x first, so the left and right first, and then we do the up or down the y, okay? Now, for slope, it's rise over run. So sometimes we can get confused by that, I've noticed, okay? Is that even though we graph, the points are plotted x, comma y, the slope ends up being like the y over the x, so they just rise over run. Because the rise rises to the top, okay? Aiden.
I don't have my glasses.
Okay? What do you mean, what points?
Like,
Aiden, would it be better for you to sit up here? Would you be able to see it if you sat up here?
yes.
Wait, why don't you sit up here? Okay? We can arrange that. Okay? Alrighty. Now we can check it. How would we check it, guys?
Plug it in.
Plug it into what?
Plug X and Y.
Plug x and y into both equations, right? And it has to work for how many equations?
Both.
Both. Okay? Do I make you guys check it?
No.
No, but you always can, right? Okay, and you can instantly know whether you guys got it right or wrong. Okay? It's kind of a cool opportunity. Let's go and work on the second one. The second one, are these solved for y yet, though?
No, sir.
No, we have to solve them for y first. Then we can graph them, okay? So go and try it. So if we look at this first equation, we have to solve it for y. So what's our first step going to be to solve for y, lady?
Solve for y.
Yep, in the first equation.
You gotta add 1x.
Yep, you have to add x, okay? So we're going to have this negative x plus 3y equals 9, or negative 9, and we're going to add x. So we're going to have 3y equals x minus 9. Now what are we going to do? Hannah, what would you do?
Divide 3 to both sides.
Yeah, divide 3 on absolutely everything. So y is equal to x over 3 minus 3, or 1 over x. 1x over 3. So what's my m and what's my b here?
Your M is 1/3.
My m is 1/3. What's my b?
Negative 3.
Negative 3. Okay, now I can graph my other one, or I can or now I can solve my other one, or I can go ahead and graph this one first. It really doesn't matter. Mason? Yes, good luck. Okay. Reagan, what would you do first to solve this equation of the 2x plus y equals 4?
Minus 2x.
Now subtract the 2x from both sides. Very good. Y equals negative 2x plus 4. Now, is y by itself?
Yes.
Nice, that was shorter. Okay, what's our m here?
2.
Okay, what kind of 2?
Negative 2.
Negative 2, or negative 2 over 1 if we want. And what's our b?
4.
4, very good. So we can go graph these equations, and does it really matter which equation we graph first? No, because at the end of the day, they're both going to get graphed, okay? So 4, go down 2 to the right one since it's a negative slope. Or we can go up 2 to the left one. And then for our other equation, we start at negative 3. And our slope is 1 over 3. So for every 1 we go up, we're going to go 3 to the right. Or for every 1 we go down, we're going to go 3 to the left. And our intersection ends up being where, Tucker?
3.
Yeah, 3 comma negative 2. Very good. Questions on this at all? Okay. Once again, could we check it? Totally, we could. Okay, but I'm not going to make you. Okay, because I had that opportunity. Okay, so now, how do we identify if something's a solution to a system? Lainey,
You plug in the points.
plug in the points into how many equations?
Both of them.
Both of them. And how many does that have to work for?
2.
Both of them. Okay? Go on, let's try one. Any Avador have questions, raise your hand. So we're trying to figure out if the ordered pair is a solution to the system, meaning does it work in both equations? So 4, 1, can somebody help me plug that into the first equation? Just has to see if it works. All right, Abby, thanks for volunteering.
Plug in 4 for x,
Okay?
1 for y.
Yeah, so 4 plus 2 times 1 equals 6. I know you guys missed that, okay? So now we just solved this. So 2 times 1 is 2. So 4 plus 2, does 4 plus 2 equal 6, guys? Yeah, so it works. Okay, on the second one, x minus y equals 3. Aiden, can you help me plug that one in? For the second equation, x minus y equals 3. Can you help me plug in the ordered pair to that?
4 minus 1.
Equals 3. 4 minus 1 equals 3. So 4 is the x, 1's the y, because it's x comma y. So what is 4 minus 1, guys?
9.
Does 3 equal 3?
Yeah.
So what's their answer? Is this ordered pair a solution to the given system?
Yes.
Yes.
Wait. What do you mean 6 and then 3 equals 3?
Okay, so we plugged it in to see if it worked. So if we plug in 4 comma 1, which is an ordered pair, so it's really x comma y, into our x and our y, do we get a true equation? Does it work? Yeah, so it works for this equation. Does it work for this equation? Yep, so it works for both. So it's the solution to the system. Does that make more sense, Mason? Thanks for asking, okay? Let's go ahead and work on the second one. So for this system, Lane, you want to help me plug it into the first equation?
Yes.
Bet.
Okay. So you'll do 2 minus 2 times 1.
What kind of one?
Negative 1.
Okay.
Equals 4.
Equals 4. Okay, so 2 minus 2 times negative 1 equals 4. 2 replaces the x, negative 1 replaces y. 2 minus, what is 2 times negative 1, guys?
Positive 2.
2 times negative 1 is a negative 2. But what's 2 minus a negative 2? Positive. So you really have 2 plus 2, right? What is 2 plus 2?
4.
Does 4 equal 4? Yep.
Do the other one?
And we do the other one. Lane, you got it?
Yeah.
I bet.
So you do 3 times 2
Yep.
plus negative 1
Yep.
equals 6.
Equals 6, okay? And what's 3 times 2?
6
Okay.
minus
S-
1.
6 plus the negative 1 or 6 minus 1, they're the same thing. What is 6 plus the negative 1 or 6 minus 1? 5. Does 5 equal 6? No, it doesn't. So is this a solution to the system? Nope. Question on that? I bet. Okay. So, flip the page with me. So if two lines are parallel, you remember this?
Yeah.
You have how many solutions?
0.
0, because they don't touch. But if two lines are coinciding, perpendicular is a neat one too, okay? Which means that they're the same what? It means they're the same line. Two lines are the same line, they're coinciding, same thing. They have
Infinite many solutions.
infinitely many solutions
I can know this.
because they share every point.
I can know this.
Because we've done this.
Yeah, makes
Top of
sense.
your head, you know it?
Well,
Yeah.
Look them high.
Yeah, Aiden.
Have you ever taken 100 pennies down to a store that was down the hill just to get pop?
No. Have you flipped your paper though to go on to the next page where we're at? Okay. So parallel lines, no solution because they don't touch. Coinciding lines, same lines. Infinitely many because they share every single point. Okay. Continuing on. So this first one, 3x plus 2y equals 6. Is this in slope-intercept form?
Nope.
No. What do we have to do to get it in slope-intercept form?
Subtract 3.
Subtract 3x 2y equals negative 3x plus 6. Now what?
Divide 2.
Divide by 2 on absolutely everything. Now, do negative 3 and 2 reduce? No, but you can write negative 3 over 2x. Do 6 and 2 reduce?
Yep.
Yeah, to 3. So what's my m, what's my b?
M is.
Okay.
Oh, okay.
B is 3 and my m is?
Negative 3 over 2.
Negative 3 over 2. Now, is my second equation already solved?
Yeah.
Oh, that's handy. Okay, I can graph either one of these first. Doesn't matter. I'll graph the first one first, though. So I'll start off, my b is 3. I'll begin with b. Go 3 up, because my y-intercept. Now for my slope, I'm going to go 3 down to the right, because it's rise over run. Or I can go 3 up to the left. Second equation. My m is what?
Negative 1.
Negative 3 over 2 is my m?
Oh,
What's with the x? What's my b, though?
Yep. Negative 1.
Negative 1. So I start off at negative 1. And my slope, what do I notice about these two slopes, guys?
Okay.
They're the same! So these are what, Reagan? Parallel. Same slope, different y-intercepts.
No solution.
These are parallel, so there's no solution.
Right there with the next one,
What do you think it is?
Neither.
So you're saying parallel, perpendicular, neither? It is neither in those, but it's a different type of scenario. So the first one, it's already solved for y. What's my m?
1 over 4.
1 over 4. What's my b?
Negative 2.
Oop.
Whoa.
Okay. Second equation, is it solved?
No.
Bummer. What do we have to do first?
Solve it.
Solve it
Subtract 1/2.
by subtract 1/2 x.
That's hard.
Negative 2y equals negative 1/2 x plus 4. Now here's the thing. How do we get y by itself now? Divide by negative 2. But wait, if I divide, I'm creating a double-decker fraction, right? So what else can I do than dividing by a number? I can multiply by its reciprocal. So instead of dividing by negative 2, I can multiply by... What's the reciprocal of negative 2?
1 over 2.
1 over negative 2. And I need to multiply absolutely everything by 1 over negative 2. On the left-hand side, those negative 2's reduce, and we're left with y, aren't we? That seem right?
Yeah.
On the right-hand side, we need to distribute. It might be a good idea to write these off to the side, saying, hey, we're doing negative 1/2 x times 1 over negative 2. So we notice on the tops, negative 1 times negative 1 is? Negative 1 times negative 1 is?
Negative 1.
Negative 1? Excuse me, negative 1 times positive 1, excuse me, is negative 1. What's 2 times negative 2?
4.
Negative 4. And there's an x still. Wait, what's a negative divided by negative?
Positive.
Positive. So we have positive 1 over 4x. Okay? And then for the second one, we have 4 times 1 over negative 2. We can put that 4, over what? 1. Does anything reduce here?
Yeah.
Yeah, 4 and then 2. There's a diagonal. Okay, what goes into both? 2. So 4 becomes, and negative 2 becomes negative 1. 2 over negative 1 is the same thing as just negative 2. So what's my m and what's my b?
M is 1 over 4.
Yep.
B is negative 2.
Very good. So it doesn't matter which one I graph first. I'll go and graph the purple one first, though.
It's the same thing.
What? They're the same? How do you know they're the same?
If you look back at the first one we did. No, we didn't really.
Okay.
It's the same equation.
They're the same equation. It looks the same as when the first one after we had it simplified already. Okay? They have the same y-intercept and the same slope. Same slope, they're either parallel or coinciding, aka same line. So now is this one, it's not no solution. How many points do they share? Every one. So it's IMS, infinitely many. Now you guys might think, hey, we're done. But wait,
We're doing another one?
there's more. Okay? I'm going to give you guys a little graphic organizer. Okay? This is going to come in handy, this chapter, quite a bit.